Kia ora Year 12 and Year 11. This is a video that's going to look at hyperbolae. So first I'm going to talk about the basic form of a hyperbola, its features, and then we're going to use what we know about transformations to figure out the equation from lots of different hyperbola graphs. What I want you to do is to pause the video every time a new graph comes up and try and work out the equation for yourself. You'll learn much more that way rather than just sitting here listening to me blathering on. Okay, so here we go. This is the basic form of a hyperbola, and it's got this form, y is equal to 1 over x. So a couple of things I want to look at in here. The first thing, and you will have done this in class, is that it's got two asymptotes. So what's an asymptote? Well, if I look in this equation, I know that I can't divide by 0. So y is equal to 1 over x. I can't substitute 0 in there, and that means that on my graph, when I get to x equals 0, there's no definition. The function's not defined there. So I get that vertical dotty line. When the vertical dotty line is the axis, we don't usually bother to put it in, but it's still there. So it's got a vertical asymptote at x equals 0. Now let's think about what else that means. Well, think about putting in a really huge number into the function. So 1 over 1 million. No matter how big that bottom number is, y will never hit 0. And the same thing if I do a really enormously negative number. It'll be lower than 0, so it'll be 0 point, the positive one will be point, let's see if I get this right, 5 zeros, and this will be negative 0.00001, but it will never touch 0, so that gives me this horizontal asymptote. Right, so that's the first and most obvious feature of a hyperbola, the horizontal asymptote and the vertical asymptote. So that one's at y equals 0. And it also has no intercepts, obviously, because of what I've just said. There is nowhere where it touches the y-axis or crosses it, and there's nowhere where it crosses the x-axis. And it doesn't have any vertices or turning points either. Right? So as soon as you see a graph with the two branches like that, you've got a hyperbola. The domain is all of the possible x values that can go in. And the domain is everything except for x is 0. So x can be any real number, but not 0. What can come out? Well, anything can come out of it. So that's the range, except for 0. Okay, so the range is the y values and the domain is the x values. So now we're going to start looking at what happens when we start to transform this graph. Right, here goes the first one. I want you to try and have a go at writing the graph for that equation. So start by trying to figure out where you think the asymptotes are. Okay, well, this is a bit mean because you can't quite spot where the asymptotes are, but they look like they might be in here. Right, so we'll play around with this a bit. When you're trying to figure out the equation for a hyperbola, this is the most general form that you can get. Now some bits of this are familiar. The plus d is what happens when you take every point on the basic hyperbola and you shift it up by d units. So the way to spot that one is if you've got a horizontal asymptote that's up higher or down lower, and that means that it's this term here that is being played around with. The a term here is to do with the squeeziness or stretchiness. Right, so it's a bit like it's just like when we had parabolas. So This term is to do with the stretchiness, or if it's a negative number up here, we can think of that as everything being reflected over. Right? The way you do this is by playing around with the graphs and with tables of numbers. Now I'm a bit mean putting in a bx plus c here. This is another stretchy squeezy factor. We're not usually going to worry about that too much. But I want to show you the most general form of a hyperbola. Usually what we'll be working with is ones that are a little bit simpler, which is these. A over x plus c plus d. Right, but I still haven't got anywhere on this graph. So I'm going to erase some of these squiggles and we'll start trying to figure out what the functional form might be. And I'm going to try and see if I can do it with these asymptotes that I think are probably at 0, 0. So we'll see if we can get something to work, and if we can, then we've found our equation. So I'll just give myself a bit more space. Right, get rid of all that. Okay, so while I'm erasing this, let's think about what points we can use here. Well, people in my class know that we always look for the blobby points. Right? So here's a blobby point here. We've got a point at 2 and 1. And here's another one. It's at 1 and 2. So that's interesting. Here's another one, a fourth one, at -2 and -1. And the next one is at -1 and -2. So some of you will spot straight away that in each case we've got a pattern where the coordinates multiply to give us 2. So it looks like we've got xy equals 2. Now if you see that, that's brilliant. We can go straight to writing the equation as y equals 2 over x. Okay, but if you didn't see it, you could write the equation like this. Well, we think the asymptotes are at 0 and 0. So we can write our equation as a over x, and just think of that as plus 0. Right, now it's a plus 0 because I haven't shifted this up. Right, so nothing's been shifted up. All I have to do now is take my y equals a over x. I've got one missing constant. I just don't know a, so I need one piece of information to figure it out. And I get 2 is equal to, 1 is equal to a over 2, which tells me that a must equal 2. So this graph is indeed y equals 2 over x. Let's try one that's a little bit harder. Okay, graph number 3. So it looks again like the asymptotes might be here and here. So we'll give it a go, which means we think it's going to have functional form y equals a over x. Right, hasn't been shifted up and down, so it's just a plus 0. So that's good. Now we're looking for blobby points. Here's the first one at 3 and -1. Here's another one at 1 and -3. So you should be getting suspicious about this by now, because we've got two more points, -1 and 3, -3 and 1. In each case, the x times the y equals -3. So that's a nice easy way to work out that the equation is y equals -3 over x. So let's think about the transformations that have happened here to my basic graph. Well, I started out, if we think of my basic form as being this one here. Oh, I'm so bad at drawing graphs. Never mind, there we go. So there we are. That's y equals 1 over x. Well, the first thing that happened to it is it got reflected. I need a different colour pen. It got reflected like that. And when we want to do a reflection in the y-axis, we get that by actually making this negative. So y equals 1 over -x. Means I'm going to reflect my basic form in the axis. Then the next thing that happened is it got stretched to y equals negative 3 over x. Okay, so you can think of that in two steps. First we had a reflection, which is when it went to a negative sign, and then we had the stretchiness to the graph. Okay, so y is equal to negative 3 over x. The domain and the range have not changed. The domain is still x is not equal to 0, and the range is y is not equal to 0. Okay, next graph. Right, finally we're going to get one where the asymptotes are not at 0 and 0. So let's pop them in. The vertical asymptote is still at x equals 0. So that's telling me that this graph must have the form something over x. But now the value that we can never reach when we put a really big number into x is not 0, but it's 1. So it's y equals something over x plus 1. So let's look at for our points. We've got a 3 there, so 1 and 3 is on the curve, and 2 and 2 is on the curve. We can substitute these in, and we'll get 3 is equal to a over 1 plus 1. So 3 is equal to a plus 1, 2 is equal to a. So my equation here is y is equal to 2 over x plus 1. Now if you're not sure about that, you can take the other point, this one here, and we can substitute into there. So we get 2 over 2 plus 1, which is 1 plus 1, which equals 2. So that's looking all good. Right, next equation. Next graph. Right, number 5. So another one with asymptotes that have been translated. So this one will have the form y equals something. Now what can I not put in to this graph? Well, I can't have x equals 2. So that tells me my bottom line must be x minus 2. And I can never hit the value 1. So this hyperbola will have the form a over x minus 2 plus 1. So again, I'm going to find some points. I've got the point 3, 2. Quite hard to find points on this one, but here I've actually got two intercepts, right? So I've got the intercept at 1 and 0, and I've got another intercept there, but I just don't know what it is quite yet. Okay, but I could figure that out later when I've got the equation. So let's now substitute in, well, let's use this x-intercept point. 0 is equal to a over 1 minus 2 plus 1. So we get negative 1 is equal to a over negative 1. A is equal to 1. This is telling me that the equation is y equals 1 over x minus 2 plus 1. Okay, so the domain here, I'll just put D, the domain is x can't be equal to 2, but otherwise x is any real number. And the range is that y can never equal 1, but otherwise y can be any real number. Now, what about the transformations that got us here from the basic form? Well, the shape of the hyperbola hasn't changed. So the first thing that happened is that I moved everything left by 2 units. So it was translated left 2, and then it was translated up 1. Okay, so that's what's going on with that one. 2 translations, 1 left and then 1 up. Right, next graph. Okay, so we should be getting pretty good at this by now. Here's the vertical asymptote, and here's the horizontal one. So my form will be y equals something, stretchy factor that we don't know yet. Now it's just going to be x in the denominator because the asymptote is telling me I can't put in x as 0. And it's been shifted up 2, so it's going to be that. Now you can probably see this one from looking, that this one is just going to be 1 over x plus 2. So if you think about this point here as being like our old origin, it's another way that you can think about these graphs when you get confident with them. Now we could check that if we wanted. We've got a point at 1, 3. So let's try and see if it works. So 3. So we'll substitute in x. 1 over 1 plus 2 equals 3 as required. So that's that graph there. Right, one last one, and then that's all on hyperbolae. Okay, so whack in the asymptotes. Here they go. So y is equal to some stretchy factor. I can't put in -3. So the vertical asymptote is at x equals -3. So my bottom line is x plus 3. And again, it's been shifted up 2. We don't know the stretchy factor. So we find a point. We'll use -2 and 1. And we could use -4 and 3. So we substitute in a point and we get 3 equals a, just using this point, 3 equals a over -4 plus 3 plus 2. So 1 is equal to a over -1. A is equal to -1. Okay, so 3 things have happened to this hyperbola since it started life as 1 over x. So I'm going to take a new slide here and I'll just talk through those 3 transformations. So here's 1 over x. The first thing that happened is it got reflected. And that was when it became y equals -1 over x. Okay, reflected, and I need to say what in. It got reflected in the y-axis. Then that graph moved, so it got translated up 2 units, and lastly it got translated left 3 units. Now I just need to check back. Earlier in the video I have a feeling I made an error when I said left or right. So if we just be careful to check that what I said made sense a couple of slides back. Alright, but that one there had the 3 transformations going on. Alright, so that's all on hyperbolae. I hope that helped, and the New Lake section on this is also really good. Thanks for watching.